Titration determines concentration by counting how many moles react using volume as the measuring tool. You start with two solutions. One has a known concentration, called the titrant. The other has an unknown concentration, called the analyte. The entire experiment is designed so that these two solutions react completely in a known chemical ratio. Here's the core idea. We cannot measure moles directly in the lab. What we can measure very precisely is volume. Because concentration is defined as moles per liter, measuring a volume of a solution with a known concentration tells us exactly how many moles were added. That is the bridge from lab measurements to chemistry calculations. During a titration, you measure a fixed volume of the analyte and place it in a flask. Then you slowly add the titrant from a burette. As the titrant is added, the two substances react according to a balanced chemical equation. At one specific point, called the equivalence point, the reactants have been mixed in the exact mole ratio required by that equation. For a 1-to-1 reaction, this means equal moles. For other reactions, the ratio comes directly from the coefficients in the balanced equation. The equivalence point is a theoretical chemistry concept. In practice, you detect something called the endpoint. This is the observable signal that tells you the reaction is complete, usually a color change from an indicator or a sudden change measured by an instrument. A good titration method makes the endpoint occur as close as possible to the equivalence point. Once the endpoint is reached, the key measurement is the volume of titrant used. Because the titrant concentration is known, you calculate the moles of titrant using moles equals concentration times volume. Those moles are then converted into moles of analyte using the stoichiometric ratio from the balanced equation. Finally, you divide the moles of analyte by the original analyte volume to obtain its concentration. For example, if hydrochloric acid reacts with sodium hydroxide in a 1-to-1 ratio, the moles of base added at equivalence equal the moles of acid present. If the reaction were one acid reacting with two base, then twice as many moles of base would be required, and the calculation must reflect that. This is why the balanced equation is essential and cannot be skipped. In short, titration works because a known concentration and a carefully measured volume allow you to calculate moles. Stoichiometry links those moles to the unknown substance, and dividing by volume converts moles back into concentration.